Hello dear students, welcome to the lecture 10 of Object-Oriented Programming with C Sharp. So today we are going to see C-Lit classes, methods, generics, with generics custom class method programming, enumerator, yield, and I will also show you something extra. So I am going to compose our project as usual. You see this is named as .NET Core, however, with the newest update of Visual Studio, now it is named as .NET. Okay, so the core keyword is removed. Therefore, if you look for .NET Core, it is named as .NET and .NET Framework. So .NET Framework and .NET. So .NET Framework is now older technology, and the new technology is not named anymore as Core, but it is named as .NET. Okay. Because some students have asked me that we cannot find .NET Core. That is why I haven't updated my Visual Studio yet. Hopefully I will update this week. Okay. I want to start the course with showing you, maybe I have shown this previously, but there is no harm repeating it. The importance of culture info. Okay, so it is a basic stuff. Therefore, we will do it and then we will pass to our, let's say, other subjects. Okay, so let's say we have a string like this, equal to, okay, A, B, C, S, and some Turkish characters. Okay, like this. So I want to convert them to lowercase. Okay, there are several ways of doing this, and let's start with the first case. Okay, so by default this will use the thread's current culture. Okay, so before doing that, let's see what is the current culture. Okay, let's see what we were using for current culture. Okay, we need to add system globalization and current culture. There is also current culture UI. Current culture UI. Okay, so this is used in the user interface and this is used in the current thread. Okay, and this one. Then with using the current culture, I will also use to lower invariant. Actually, to lower invariant doesn't change. Lower invariant, and then I will use a specific culture method. You see, to lower gets culture info as well, and when I type new, it will automatically tell me that I should compose a new culture info like this, and here I will provide the Turkish culture, TR. Okay, so let's run our application and see how they behave. I am not going to do anything else. I will just use debug for showing you the effect of culture. This also affects how you convert your variables. Also, let's make that. Okay, convert to double. Let's convert this one. And does this take culture anywhere? Okay, and then dbl2 like this. Okay, let's run the application. Okay, let's continue. So the current culture of the thread is United States English. UI culture is United States English, which is my computer culture. Then when I convert these to lowercase, they are converted like this. Okay, so let's see which character is lost. Okay, no character is lost in this case. However, let's say I also add bigger I like this, and let's see how they will be converted. Okay, so bigger I is converted as I don't know how it is called read in English like this. So we have lost our Turkish accent. Okay. If we use to lower invariant, they are converted like this. So let's type their results like this, and the result is like this and like this, and then I will continue. I haven't saved it yet, so it should work like this. Okay, you see they have produced different outputs. The bigger I is not converted to lowercase in to lower method and to lower invariant method. However, when I provide Turkish culture, it is converted to lowercase as expected. You see the difference? And let's also see the result of double. So the first double conversion is made like this, and the second double conversion is made like this. Okay. And if I set the thread culture something different, let's see what will it generate by then. How will I do that? I will do it like okay. Maybe it is set from here. Okay, there is default thread culture. Okay, current culture. Can we set it like this? Yes, it has get and set, as you can see. Therefore, I can set it. So I will change my thread culture to Turkish culture. Okay. From now on, from this point on, the culture of the thread will become Turkish. So this has output of EN/US, and this has output of EN/US. So I am copying and pasting this entire thing to here. Of course, I have to remove type definitions because they are already defined. And let's run a debug and see how they are behaving when I set the culture info of the current thread. Okay, let's move. Okay, so you see now it is TR and this one is still English US. Therefore, the UI thread is still using English US culture. However, this thread, which is the main window code behind thread, is now using Turkish culture. So let's write the output like this. So the output becomes this, and the lower invariant. Oh, did I save it? Let's rerun it. One moment. Okay, and let's see the invariant. Invariant is like this. So the invariant should not change. It is independent of the culture. And of course, the Turkish culture is like before. And let's see the conversion of double. Okay, you see this time this is becoming like this, and the other one is becoming like this. Okay, so how you set your culture makes a huge difference. I want to also show something else. What if we start a sub thread, okay, or a new thread? So let's make example of that as well. Private void test thread or task, okay, and here I will use the same. Okay, so by default it will be all, of course, English. Therefore I will call thread after here, and thread, how do we create new thread? We need to add system threading. There is also the tasks. Okay, and new thread. Actually, I don't remember the syntax. Okay, so thread start will be like this and start. Okay, so let's see how it behaves in thread, and I will also test it in the task. Okay. Okay, so the thread starting this subthread is using Turkish culture. Let's see how it is in the subthread. Okay, it is Turkish culture as well. Okay, so this time we will get the same as Turkish culture. We just need that to know actually. And let's test the task method. I didn't check the rest because we know that how will it be. By the way, when I have renamed this, it will tell me that to fix the naming. Okay, it doesn't show me anyway because I did more things. Okay, test task. So let's test also task. Start new. Okay, and I could use the same method, but in order to be sure and if necessary write different command, I have made it like this. So this time we are using test task. When you are developing your application, you have to consider that your application may be used on a different culture. Therefore, be sure that, okay, so this is the same as starting sub task. Okay. Okay, I think you get the idea. So we can move to sealed classes.
Sealed class in C#. In this article, I will discuss how to create and use a sealed class using C#. We will also see why developers use sealed classes in their libraries and code. Sealed classes are used to restrict the inheritance feature of object-oriented programming. Once a class is defined as a sealed class, this class cannot be inherited. In C#, the sealed modifier is used to declare a class is sealed. In Visual Basic.NET, not inheritable keyword serves the purpose of sealed. If a class is derived from a sealed class, compiler throws an error. If you have ever noticed, structs are sealed. You cannot derive a class from a struct. The following class definition defines a sealed class in C#.
Okay, so this is about sealed classes. In sealed classes, you cannot compose a child class. I mean, you cannot inherit a sealed class. So let's add a button to make some tests. It is so simple thing actually. Okay, and let's compose a click event. Okay, so let's try to generate a class inherits a struct as mentioned. So I will say that and I will try to inherit integer. Okay, integer is class or struct? It is a struct, yes. Okay, you see, now it is preventing me to compose a class like this. Why? Because it says that cannot derive from a sealed type integer. So as from here, we see that it has read only struct. Okay. However, may I inherit from string, which is not a sealed struct, but it is actually it is also behaving like a sealed class. Why? Because it is immutable. Okay, it says that you cannot derive from a sealed type string. Okay, so string is also a sealed type, and let's see why. Because it is immutable. Let me show what I mean. That is my guess actually. We will see that why. Yes.
String is sealed mainly because it is immutable and CLR widely uses that feature interning, cross-domain marshalling. If string would not be sealed, then all CLR expectations on string immutability would not cost a dime.
Okay. CLR is the common language runtime. Okay. So what was the immutable? Let's remember it as well.
An immutable object is defined as an object that cannot be changed after it has been created. For many use cases, such as data transfer objects, immutability is a desirable feature.
Okay, what does that mean? That means that let me show you what I mean. I will show when we define a class. So this is not allowed. Okay, so I'm just going to comment this out, and let's continue with the example. So we have sealed class like this. Okay, and then inside it we have a method like this. Okay, now this class cannot be inherited from any other classes. So let's show what do we mean. And I will try to inherit this one. You see, cannot derive from sealed type, sealed class. Okay. Type object. By the way, we can use sealed keyword for other things as well, I think. Okay. So this will also fail. I am going to comment it so it won't be updated. I mean, it won't cause any problem when we run the application. Let's continue. By the way, I was going to show the immutable. So in our button call, I am going to compose an instance of our sealed class. And then I can run the method. It has like this. Okay, so this returns an integer. So let's use integers. I wonder if we can get something. So you will understand the immutable object or struct difference. Okay, anyway, I have shown what that means, but whenever you make a change in a not reference type or a immutable type, it changes its reference. What does that mean? That means that sr test equal to something, and when I make sr test as something 2, now this composes a new object of string. Okay, we don't use the previous composite object, therefore it gets garbage collected. Okay, this applies to this one as well. This one also composes a new object because it is struct type. However, for my sealed class, I can do something like this. Let me show what I mean. My test class 2, my test class 2, and then I can assign my test class to my test class 2. This just copies a reference of memory address, we can also say. My test class 2 to my test class, because these are reference types. Okay, we have shown what these mean in the previous lectures. You may want to rewatch if you don't remember. However, I just wanted to mention them again. Okay, I will show you the memory addresses there, but it looks like by default they don't have fixed address there, therefore we cannot see them. There is unsafe code, but I won't waste time with that.
MSDN updated, sealed methods and properties. You can also use the sealed modifier on a method or a property that overrides a virtual method or property in a base class. This enables you to allow classes to derive from your class and prevent other developers that are using your classes from overriding specific virtual methods and properties.
Okay, so let's make example of this as well. So we have a regular class, name it as X. However, they have protected virtual to method. It has, let's say, and let's make this as message box shown, or let's make this as debug write line, so we can see while it is running. Okay, and then we have another class which inherits from class X. So class Y inherits from class X, and it overrides the virtual method f. However, with a sealed keyword, it overrides it, and it also overrides the method f2. Okay, and then we have another class which inherits from class I. And when we try to override method f, this time it cannot, because its parent class is having a sealed method. As sealed. Therefore, I will just make it like this, and we can override the F2, okay, like this. All right, I won't run it because it is very obvious.
Why sealed classes? We just saw how to create and use a sealed class in C#. The main purpose of a sealed class is to take away the inheritance feature from the class users so they cannot derive a class from it. One of the best usage of sealed classes is when you have a class with static members. For example, the pens and brushes classes of the system drawing namespace. The pens class represents the pens with standard colors. This class has only static members. For example, pens, blue represents a pen with blue color. Similarly, the brushes class represents standard brushes. The brushes, blue represents a brush with blue color. So when you're designing a class library and want to restrict your classes not to be derived by developers, you may want to use sealed classes.
Okay, this is why you may need it in future, or you may encounter such case. Therefore, you just need to have an idea what is a sealed class. I am adding the reference as well. Okay. Okay, so let's take our notes as lecture 10. Okay. Okay. Okay, I want to also test something else. Meanwhile, our subtask is running. If we change our main class thread, what happens? Okay, so let's test that as well. So this is our test thread, and in the test thread, what I'm going to do is while true, it will just loop through these commands, okay, these lines. Let's add a system threading sleep, so it won't consume my whole CPU. Okay. Let's copy paste this to other method as well. Okay. So meanwhile, these tasks are running. I am going to change the thread culture, the thread that has spawned them. Okay. I think it won't affect them, but I want to be sure. Maybe it will. Okay. So I'm going to put a breakpoint here. Since they are subtask and subthread, they won't block my application. Okay, so currently these are running. Okay, these whiles are running. If I put a breakpoint here, oh, application has entirely stopped. So my best option would be using a button to change it. Okay, I will do that. Okay, let's run the application. Also, let's get the current culture as well. Okay, so my while loops are working. Let's put a breakpoint here to see. Okay, so they are currently Turkish and UI culture is English. And let's move to here. This is also Turkish and UI culture is English. Okay, let's continue. Okay, after I click this button and change the main thread which has spawned those subthreads, culture, will it affect them or not? I believe it won't affect them, but I want to be sure. Okay, so let's see. So the current culture of the main thread, we are still in the main thread, you see, because we are at the same level of main window class. And then I will change the current culture. Now it is English US. Let's continue. Okay, let's click it again and see the current culture is changed or not. You see it is still English US. Let's continue. Now I will put a breakpoint here to see whether any changes is made or not. Okay, it is still Turkish. So each thread keeps its culture information until it is terminated. Okay. Uh, um, okay. Okay, so okay. Other than methods, can we compose any other thing? Okay, we can also use that on properties. Let's make an example of property as well. So, what kind of property we may give an example? Hmm. Okay, let's try a prop like which is not a struct type. Okay, let's say and can I override this? I wonder that. I wonder if this is possible or not. Let's see an example. Okay, yes, this is a property. Oh, I see. This is how we override it. Yes, with defining get and set. Okay, so let's use property string name, and then we should be able to override it. Okay, string. So here I am overriding the property. By the way, for this property we define it and overridden, we have to have a private variable like this. However, if we define private variable, we can't access it. And we have to make this, I think, abstract virtual. We have to mark this as virtual. Okay. Then says base my property. Yeah, we can use it like this. Okay, so we are, you see it says x dot sr name. So x is our base class. I will make it like plus overridden. So when returning, it will return this keyword, and when assigning, I will assign it as value plus 1. Okay, whatever, it doesn't matter. So this will override the sr name, which is basically a string property. And when I override, I will also add sealed keyword. Okay, so I won't be able to override it in the class Z. So this will tell me that it is sealed. Okay. So this is how we override properties. Let's show an example of that. So let's define x equal to, okay, and let's give it a name, test. Okay, and then let's class I from I. Okay, let's give them as name x, I, and z. Okay. And here I will make them like this. Okay, and so let's see how we will be able to read them. Okay, so you see this is as x. Why? Because in x class, it is basically a string. It is behaving like a field currently, because we use the default get and set. Okay. So in the I class, what do we expect? We expect that I, then 1, then overridden. So the result we will see will be like this. Let me show you. I haven't hovered yet. It will be equal to I1 overridden. This is the result that we are going to see. Let's check it out. You see I1 overridden. Why? Because in the set method, we add space and one character to the end of the string and at the get method, whenever we read it, we add space and overridden. Okay. And the third one will be equal to same as I class, because it is inherited from the I class. Okay. So if I make it like this, I then, yeah, I don't need that. Okay. Okay, now we get the idea. Okay. Okay, what else there is? Okay, I think we have shown enough information for the seal it. Then we will move to generic, which is really important part of C# programming, generic methods. Okay, so I will take a pause here. Okay, so what are the generic classes or generic methods in C#? Okay, let's see. Okay, let's learn about generics. This is an extremely useful approach in C#. Okay, I think I will move from here.
C# generics. Generic means the general form, not specific. In C#, generic means not specific to a particular data type. C# allows you to define generic classes, interfaces, abstract classes, fields, methods, static methods, properties, events, delegates, and operators using the type parameter and without the specific data type. A type parameter is a placeholder for a particular type specified when creating an instance of the generic type. A generic type is declared by specifying a type parameter in an angle brackets after a type name, e.g. type name less than t greater than where t is a type parameter.
Okay, it is defined like this.
Generic classes are defined using a type parameter in an angle brackets after the class name. The following defines a generic class.
Okay, it is like this. You see, data store is the class name, data is the property name, and their type is set as T. You see, generic type.
Above, the data store is a generic class. T is called type parameter, which can be used as a type of fields, properties, method parameters, return types, and delegates in the data store class. For example, data is generic property because we have used a type parameter t as its type instead of the specific data type.
Okay.
It is not required to use t as a type parameter. You can give any name to a type parameter. Generally, t is used when there is only one type parameter. It is recommended to use a more readable type parameter name as per requirement like t-session, t-key, t-value, etc. Learn more about type parameter naming guidelines.
Okay. And
You can also define multiple type parameters separated by a comma.
okay. So we can also define like this t-key and t-value. When it is not one of the defined types in C#, the compiler understands that it's a generic type. Therefore, you can give any name. I don't know if the T keyword is necessary in front. Let's test it. Okay, key value pair is the class name. And tk, can we call it as ak? Yes. You see, since there is no such data type as ak, it understands that it is a generic type. Therefore, it doesn't matter what you write, okay, as long as that name is not one of the data types in C Sharp. Okay, so the naming is not that important as long as you give as a you use a defining name. Okay.
Instantiating generic class. You can create an instance of generic classes by specifying an actual type in angle brackets. The following creates an instance of the generic class data store.
Okay, when you are instantiating a generic class, you always have to use a real data type. Okay, so these are for the generic type is just for definition. However, when you are going to use an instance of that generic class, you use a real data type. Okay.
Above, we specified the string type in the angle brackets while creating an instance. So, t will be replaced with a string type wherever t is used in the entire class at compile time. Therefore, the type of data property would be a string. The following figure illustrates how generics works.
Okay.
You can assign a string value to the data property. Trying to assign values other than string will result in a compile time error.
Okay. So once you create an instance of the generic class, then you cannot change its type. So what does this mean? Let's start applying the examples so we will understand better, and you will also understand the aim of using generic types, which is extremely useful. Okay, so here, so let's define the generic data type. So basically this class holds a generic data property, and here I am defining an instance of that class, instantiating it with string. Therefore now I can use data of data store as string only. Okay. After this, I cannot do like this, equal to this fails, because once you initialize it, with a certain data type, you cannot change it again to different data type. However, what I can do is something like this. So I will make it as market, and this time I will use double. Okay. And okay, market dot data can be equal to this. Okay, so this is what our generics about. You define a structure, then you can use that structure with any data type. Okay, that supports generics. I think all types might be supporting, but I am not sure. So this throws compile time error. Okay. Okay, so there are some other examples. Okay, I think these are good examples as well. You see, in the first case, the key value pair is defined as integer and string. You see, it shows that tk is integer, t value is string, and in the second example, tk is string and the t value is string. Okay, so it is up to you how to use generic types. The list method we have been using is also a generic type. You see, represents a strongly typed list of objects that can be accessed by index. Provides methods to search, sort, and manipulate lists. T equal the type of elements in the list. So the list class is actually a generic type. However, when we define it, we always use a specific data type. Okay, so I cannot define something like this. This doesn't work. Okay, I cannot use something like this. I have to use a real data type. Okay, and we have seen the real data types in C#. Okay.
Generic class characteristics. A generic class increases the reusability. The more type parameters mean more reusable it becomes. However, too much generalization makes code difficult to understand and maintain. A generic class can be a base class to other generic or non-generic classes or abstract classes. A generic class can be derived from other generic or non-generic interfaces, classes, or abstract classes.
You see, it is extremely flexible. It supports all of the approaches that may come to your mind.
Generic fields. A generic class can include generic fields. However, it cannot be initialized.
Okay, so in here we use property. This is property because it has get and set. However, for example, in this case, this is a generic field. And I will call it as version 2. In this case, it says that it cannot be initialized. What does that mean? You cannot initialize it in the class, I think. It is what does that mean? Let's try it. Okay, I have to define its data type because it is expecting from me a data type here. You see, normally we don't put anything in front of class definition. However, when it is generic, I have to provide a T generic type value like this so that compiler can understand it is a generic class and it is taking a generic type and which can be used inside the class. So let's test with integer and okay, and test dot data equal to something like this. Okay, I think we cannot initialize it with a default value like this. I don't know, let's try it. Okay, cannot implicitly convert type to integer. Okay, yes. Okay. However, this works. Okay, so we can also define generic array like this. Okay, array data store, and this is an array with length of 10. However, you see its type is still t. So this is just initialize an empty array, and we can also have list from t type and list t. And can I have something like this? I wonder that. Yes. So you see that in a generic class, I can also have non-generic fields, methods, and properties. For example, I can write a method. And I can return these LST names, first or default. Okay. So this works, or I can have another method, public t. This will return a t type and print data and return this data 0. Okay, so you see this also works, and I can have generic and non-generic properties as well, such as integers. So this is another generic type. I can assign also it like this, or I can have a generic property. We also had made example of that, t. This. Okay, every one of these works, and you see there is also generic methods. I already shown it, but
Generic methods. A method declared with the type parameters for its return type or parameters is called a generic method.
okay, so if it is taking a generic item or returning a generic result, it is it is called as generic method. Let's copy and paste this. Let's call as so in here it holds a private generic data array. Then it has two public methods. There is add or update, which takes the index and the t item. Then it has get data method, which takes index. So this is like generic array which C# already has. Let's define like that. By the way, I have to define its data type. I will use this time float, for example, and it will automatically tell me to complete like this. Then my generic data holder I can use add or update. I will add a float like this. Okay. Then I will add another one like this, and then I will do a for each inside. I wonder if it will support it. No, it doesn't support because it doesn't have enumerable interface. And then I will get the value, or let's just put a debug to see how it is holding the values. Okay, currently it has all 0 because 0 is the default value of a float type. Then okay, the first index has this one, and then it is updated to this one. Okay, anyway, it is all about how you are coding these methods. You see, when you are providing something out of the range, it returns the default type of that data type. For example, and I will provide like this. By the way, it has get data and like this. So this will return me 0 because that index does not exist. Let me show you. Okay, I am clicking it. So I will enter inside of the method call. Okay, so the index I have provided is 3212. Since that index is out of my index range, my array only supports 10 elements. It will return the default type of t. In this case, the t is float. However, we can't see it from debug, I think. Oh, we can see here. And then the default of float is 0, therefore it is 0. I could also define it like this. String and holder. And this time I can add like this because it is inherently. Oh, one moment. Oh, it doesn't convert them inherently to string. Therefore, I will call to string method. And I can call it like this. You see, if I make it like this, it will give me an error because because this one is float type and this one is string type. Therefore, I need another variable. Okay, so let's put a breakpoint here. What is the default value of string type? It is null. Okay, so you see this is null, and all others values in the array which is not initialized or assigned is by default null. Okay.
Above, the adore update and the getData methods are generic methods. The actual data type of the item parameter will be specified at the time of instantiating the data store less than t greater than class, as shown below.
Okay, this is the moment where you initialize, where you instantiate. This is hard to pronounce.
Instantiating.
Okay, this is where you instantiate the data. I am having hard time to read it. Oh, there is also try it button. Let's see. Okay, so it shows the output as console write line. Nice. And we can also change it something like this. Run. Yeah, working. If I change it like this, wow, it says that it does not exist in the current context because it is assuming a data object, name it as this. If I make it as string, okay, it says it cannot confirm from string. Oh, nice. Their interface is really good. Okay, and
The generic parameter type can be used with multiple parameters with or without non-generic parameters and return type. The followings are valid generic method overloading.
Okay, so okay, these are generic overloadings. Let's check them. Okay. By the way, they have to be inside a generic class. So let's define our generic class. T. And because they are expecting the T. And yes, it is working. However, if I make it like this, I think it will throw an error. Yes, it is expecting at least some different signature. So here it is taking U. So what does this mean? Oh, it is expecting a different generic parameter. Where does this U come from? Okay, the U is taken from the method itself. Okay, oh, I see. So let's make example of this. I think this is a good example. So what is the difference between this one and this one? They look same, right? They have two generic data input. However, this one is taking the second type of generic data from the method call. Okay, so let's compose an instance of this class. Okay, and I will define a type as double. Okay, I think I have to provide it here. New. Okay, then I can call these methods. For example, add or update. Okay, in this case, okay, I am getting an error. Why? Because it says the call is ambiguous between the following methods or properties. It can be both integer and t, or t and u. Therefore, I have to specify it. How can I specify it? I can specify it like this. Okay, this works. Why? Because this is equal to this one. And I can also write it like this. Let me show you. Integer and like this. Okay, so this one is being equal to this one because the first value is integer or double. In this case, it is double integer at double data and integer. Okay, so this is equal to this one because it is counting the first one as double in this case, because our type is double. If I want to use this one, this is the way. So this one goes to this one, and this one goes to this one. And if I make it like this, let me show you. Let's give them a number. Number 1, number 2, number 3, and number 4. So the first case is index and data. So it is number 1. Okay. So this is equal to number 1. Okay. We can also test it. Let's do it. Actually, this can be equal to number 2 as well, because this can be counted as double as well, but I am not sure how will it behave. I think it will behave as this integer, not double. So this is number 3, obviously. And let's do like this. Okay. So this should be equal to number 2. 2. And the final one is already have a different signature. So it is like this. Whatever I write here, this is number 4. Okay. All right. So let's test our theory. So number 1, number 2, number 3, and number 4. Okay, so when I execute this line of code, it should show number 1 in the message box. Okay. Okay, when I execute, okay, number 1 is executed. Yes, we have correctly guessed it. And this should execute number 3. Number 3 executed. This is number 2, and the last one is number 4. Okay. So let's continue.
A non-generic class can include generic methods by specifying a type parameter in angle brackets with the method name, as shown below.
So it can be also like this. So you can define a generic method inside a non-generic class like this. Okay. I think this case will be also valid. So I'm going to comment them out, or not comment them. So I will provide something like this. Let's call this as T1, T2, T3, T4, and then let's give them different names. So the first one will be first name and surname and age and let's say score. Okay, whatever I want. I'm giving the names like this. And here I will use each data as first name, VR1. Okay, and then second surname as VR2, age as VR3, and score as VR4. And here I will show this. So the name, or let's write it like this. VR1 to string, so I can define it. By the way, if you are expecting a certain type, you should not use generic types, because in this example I am expecting some certain type. However, I am defining it. I will make it like this. One moment. So let's remove this and remove this. So let's make this string and string and age and score. Okay, so this will be more sense making now. Okay, and then VR2 is let's say we are 3 years old. By the way, I will convert this to string. So the type I provide has to be string convertible. Actually, almost all of the objects are string. I think string method, yes, it supports any object probably. You see, it takes object and got we are 4 to string score. Okay, so let's compose a printer class object. So I have to provide the types when I am instantiating it. So the types I will be providing with will be age. The age can be integer and score can be anything. Let's provide double. Okay. And print class is the object name. And print class and use print method. You see, it is expecting me to by the way, I can't define it like here because it is not a generic class, therefore it will be like this. And I will provide the data types in the print method when I am calling it, and I will provide then the value as example student. Let's say the age will be 23 and the score will be, okay, let's make it like this. Okay, and in another case I can make it like this: printer class 2. This time I will use double and let's say integer. So now I can define a double age and integer score. Let's say example to student. Okay, it is up to me to provide to decide which types it will be using. Okay, number 1, 3, 2, 4, and example student is 23 years old and got 78. You see, it has used the comma instead of dot. Why? Because our current thread culture is set as Turkish, therefore it is. And you see, it has used comma here for separating thousand, for separating floating point numbers. So I will change the thread culture before I call these methods. How will I change it? I will change it as current culture info current culture. You see, the current culture supports both get and set. It's a property, therefore I can set it, and I will set it as new culture info and English US. Now you will see the thousand separator will be dot instead of a comma. Okay. Okay, you see it is dot right now, and you see it is dot as well right now. Okay, and let's continue. Okay.
Advantages of generics. Generics increase the reusability of the code. You don't need to write code to handle different data types. Generics are type safe. You get compile time errors if you try to use a different data type than the one specified in the definition. Generic has a performance advantage because it removes the possibilities of boxing and unboxing. Share
Okay.
tweet, share WhatsApp, previous, next.
Okay, generics are really important because if there weren't generics, we wouldn't have a class like list that we can compose list of basically any object. It can be dictionary, it can be double, it can be list of list and another list and another list, whatever. Because it is a generic type, therefore it supports all of the data types. You see how powerful it is. Generics are so powerful as long as you use them properly. They can be used in anything, in abstract classes, in virtual classes, or whatever you want. So they support basically everything. Generics and non-generic classes methods can be mixed. Okay, so let's see if there is anything different in the example of Microsoft. So you say it says this one generates an error because it is inheriting a generic class which uses T and U as generic data. However, if you provide only single generic data, it throws error. I also like the this side of C# because it's a strong typed language. Therefore, if there are errors in your coding, you are warned at the completion time, so you don't make such easily fixable mistakes. Okay. All right. So as next, okay, there is system iComparable. iComparable is something different. And oh, okay, there are constraints. So let's see constraints as well, and iComparable as well. And I enumerated and yields. Okay, let's continue with iComparable. So what is iComparable and how to use it? And
C# iComparable interface. The iComparable interface defines a generalized type-specific comparison method that a value type or class implements to order or sort its instances. The iComparable is implemented by types whose values can be ordered or sorted. The interface requires the compare_to method to be implemented. The implemented method is automatically called by methods such as array, sort, and ArrayList, sort. The interface is used by types that the programmer has control over, in other words by code that he has written. If the code is provided by someone else, we use the iComparer interface instead.
okay, why we may use something like this? Because these are both printer types. However, I cannot compare them like this. If I compare them like this, I don't know what will we get. Let's see. Okay, this wouldn't be a this would only compare their reference address. Okay. For example, this will be false. This one is false. However, if I make it like this, equal to this one, then this will be true. Why? Because now their references are same. Let me show what I mean. Okay, you see this is a printer class 1, printer class 2, and it is false. And then I will assign the reference of printer class, print class 2 to print class 1. And now you see it has compared their reference. Okay, however, if they were something like this, so I will make the example duplicate so it will be understood better. So printer class 3 is exactly same as printer class 1. Okay. Therefore, when we compare them, and oh, by the way, each time I see they were already same because the method is different, not the class itself. However, if you would have a better example, I think it would be better. So I'm just deleting this to make better example. Okay, so this is a good example. So let's add a button here and let's name it as iComparable. Okay. So let's move this to the end and let's compose the class. Oh, so this is where our main window ends. Okay, I will move this to here. Okay, yes, correct. Okay, so first define the employee class without iCompare interface. Employee no compare. So it has string name as property, salary as property. I'm removing this. And it has toString method. Okay. So the string toString method is an override of the default toString method. Why? Okay, let's see what was each one means. Okay, when I remove this and do something like this, you will understand what I mean. Okay, let's make two versions. And okay, and yeah, I had some extra bracket. Now compare version 1 and version 2. Okay, so let's first compose an object with version 1. v1 equal to like this. I can also define the value as Furkan and salary, let's say 100. Okay, I think I have to provide the variable names. What like? Okay, so if I do like this, v1 to string. Let's see what do we see. Then let's compose version 2 of the v of the same class and use that as well. So this is version 1 and this is version 2. Okay, let's run the application and see how does it behave. Okay, you see version 1 shows me the name of the class, full path of the class. Okay, lecture 10 main window plus employee no compare 1. This basically gives us no information. This is not what we want. Therefore, we override the method extension of toString because the toString has can be used for any object. However, this time I am overriding the toString method for this particular class. So let's see the second example. You see it shows what I want, version 2 Furkan 100. Okay. Even though they are same, if I use it like this, v1 equal v2. Okay, let's say you see they are already not equal. However, it is fine. This is expected because they are different class. Let's make something like this, version 2 v2 2. And you see they are basically same actually in terms of values they contain, equal v2 2 and else okay, and else message box show v2 is not equal v2 2. Okay, if I compare them like this, it will only compare their reference. This will only compare their reference address. Okay, not their values. Actually, they are same because you see they are same. They are initialized with same parameters. However, since they will have different references, this will tell me that they are not equal. Let's say I make another class or reference like this, or if I make their references equal, it will be of course correct, but this is not a good way of explaining it. So then what we need to do is for comparing custom class objects is using iComparable, okay, interface. So it is this one. This is the code we have taken from the example. You see it is inheriting iComparable interface. Okay. You see it says defines a generalized comparison method that a value type or class implements to create a value type or class implements to create a type-specific comparison method for ordering or sorting its instances. So the iComparable interface takes t value as employee because this is a generic interface you see in t, and since our class is employee type, we name it as employee. We provide employee as type, and it implements public integer. Okay, this is what we have as written. I will provide this as boolean, and I will use something like this. They have only compared the salary However, I will compare the both values. So if this dot salary equal other the salary and this dot name equal other dot name return true or otherwise return false. Okay, I don't even need to use else because if this is not executed, this will be executed. Then I can compare them. Okay, so oh, it is expecting integer. Why? Does not have the matching type of integer. But why I cannot return boolean? Let's check this out. Does not have the matching return type of int. You see, you should be careful with the errors that your compiler shows you to solve your problem. Okay. Cannot convert type bool to integer. I see. Comparable implies that two objects can be compared in a sense that you can tell which object has higher value. It is generally used for sorting purposes. You should override equals method instead. I see. So to do that, we need to use equal method. Okay, and equal method uses equatable. Okay, so if I make it like this, and okay, so equals is a special keyword. Okay, I see. So this is used for comparable used for sorting. Therefore, it is not what we want. In our example, it is equatable for checking them as equal or not. Okay, so this will work. Now I can apply the same methodology. So I will also make a good example of comparable as well for you to for equatable. I wonder if we can also implement comparable. Yeah, probably we can. And then we can compare their salaries. Okay. And to compare their salaries, yeah, this makes sense. Now it can return integer. And this time, yeah, we will be implementing both interfaces. Yes, this is a good example now. Okay. So now we can sort them or compare them. Okay, nice example it is being. It says compare to. So it is expecting a special keyword. And okay, and now I can show you what we can check whether they are same or not. So I am going to use something like this. Version 1 and version 2. Okay. Okay. I need to give them a new variable name. Okay, now I can see them. They are equal. Okay. Let's run it. So now it will use the compare method we have implemented. Not it will check the references of those objects. And okay. Oh, I have to use not the equal. This is Boolean object operator. We have to use this. This is still checking the reference. I have to use compare to. Okay. And by the way, equal to, not compare to, equals. Okay. UT EV1 is equal to EV2. Nice. And we can make something like this. This is for equality checking. If I make it like this, let's just change the salary to like this. This time it won't work. They won't be anymore equal. You see, I have added this one to change it is as equal to false, or as we can also type it like this. Okay. Is equal to and is not anymore equal to. Okay, now I will show you the I compare method. This will be a good example. So I am going to define a list based on the type of employee. And I will generate 100 employees randomly equal to new employee, and name will be E plus I, and the salary will be something random. Okay, so let's make it like and okay, and now I can sort this list. Okay, at EE. Okay, let's sort them. How we will be sorting it? We will sort it with list. I think, yeah, this way. So since we have implemented iCompare compare to, we should be able to sort it. Okay. If we had do this in, let's say, this method, like here, it wouldn't work. Let me show you. Okay, and sort. Okay, let's try it. Okay, it's already thrown an error. Okay, yeah, it was due to this. Let's rerun. Okay, so our first list is like this. So these are their values. You see they have random order right now. And let's see the sort method result. Okay, it says failure to compare two elements in the array. Inner exception, argument exception, at least one object must implement iComparable. Okay. Yes. Why I cannot copy this? So this is a runtime error. Therefore, these are more dangerous ones because you can't know them until that event occurs during the runtime. And however, this should work. By the way, I am using these interfaces first time also. I have never used them before because in none of my project I needed them, but they are extremely useful and you may be needed to use them. Okay, so right now they are in random sort and let's check them. Okay, so they are sorted from, yes, with the descending order. Okay, so by default we have sorted them by salary with the descending order. Why is that? Because in our compare to, it checks that if salary is smaller than the other compare salary, return 1. And if it is bigger than, return -1, and then it returns 0. So this is by default sorting descending, and if we use order by ascending, sort by, I think there is no sort by ascending. Yeah, there is no sort by ascending. However, if I happen to change these two, -1 and 1, this time it should sort it by ascending order. Okay, let's check. Currently unsorted, and now, yeah, you see sorted by ascending. Okay. So let's say so with this way, if I reverse it, I can obtain ascending like this. So this one will be, or let's say, by the way, you could also sort by its name. It is totally up to you. We have used this comparison, but you can use any comparison. Let's say if you can also say that if their salary is equal, then sort by the first letter of the name or such, or your class may have another additional property. By the way, your class must use probably properties. If this become a field, I think it won't work, but I am not sure. Let's try it. Will it work or not? I am not sure. It may work or it may not work if this is being a field. Okay, at compile time we didn't get any error, but in runtime, yeah, it is working. So it can be either field or property, doesn't matter. And I may have also, let's say, let's also define age. Okay, and if I also set age like this, go to next. I could also sort them like this. However, this will generate an integer bigger than integer, therefore it may not work. Yeah, it may throw an error because when you multiply two integers, it will be too big. Therefore, we need to change these to int 64. Let's change them to int 64. Okay, now it should work because this round next generates only integer. Okay, and this will be other. So the comparison is totally up to us. It will work in either way. Okay, you can also make, or you can also sort them like this. So this time they will be sorted by their by the multiplication of their age and salary value. Okay. Okay. So now we can see, you see age and salary and age and salary, and when they will be sorted, they will be sorted by the multiplication of their age and salary. So this one has the biggest age and salary. Okay, you see. Okay. I think you get the idea. What other interfaces there are if we look? There is iClonable, iComparable, iConvertible, iCustom Formatter, iDisposable, iEquitable. We have already used this, and we have already used this iComparable, and iFormat Provider, iFormatable, and such. iObservable. You see, iProgress. There are many other interfaces that you can use. Okay, so we have seen this, and we can also add constraints to our generic classes. So what is being a constraint, if you ask, if you wonder? Constraint is something like this. So I have defined a class which takes three generic data. However, the third generic data has to be iComparable, has to support iComparable interface, and the second type has to support new keyboard. Therefore, it has to be an initializable data type. So let's see what kind of effect it has. Okay, so I can define the first type anything I want. So you see it is showing me that where v equals new. So if I do it like this, it will throw an error because, oh, it does support perhaps, I don't know. And let's see. So yes, so these are not the good example. That's something that cannot be read. Enum. Yes, enum is not. Okay, now it is. It will throw an error. Okay, it didn't accept the enum. What else I can give a good example? Maybe I can define another custom class to do it, which doesn't support new keyboard, or let's make it as, okay, iComparable. So our class employee no compare doesn't support iComparable interface. That due to that, okay, you see it says me that cannot be used as type parameter u in the generic type or methods. There is no implicit reference conversation from to that one because it doesn't support iComparable interface. So this is a restriction that I can put. I can also make like this, where key must be a struct type. Okay. So if I define it like this, that time this would also fail. For example, okay, it says that the type string must be non-nullable value type in order to use it as parameter key, because I have limited it with like this. I can use such limitations, such constraints when defining a class. Constraint, and constraint. Can I define multiple constraints? I wonder that. Let's see. For example, I am expecting this And key bigger than 10. I wonder if we can do something like this. Okay, no. Okay. So we can define multiple constraints, I suppose. So we can apply new class. However, what is the format? Oh, I see. So the class has to be first and then, okay, so you can define multiple constraints like this. Okay. All right. And okay, this is also important. Let's read it.
Generic classes are invariant. In other words, if an input parameter specifies a list less than base class greater than, you will get a compile time error if you try to provide a list less than derived class greater than.
Okay, and I think for this week these are enough. So that's I will show this at the next lesson. And let's write the other things we have seen. Okay. Okay, and methods. Generics. Okay. And using okay, I think this okay. How to inherit multiple interfaces at once, and what other there we are. By the way, these constraints can be used at anything. That we can use this in I think method definition as well. Let's try it. So t private t test method which takes parameter as t and return t, and here I will try to put a constraint where t is a struct. Okay, so maybe we need to put it here. Let's no, not this one. Maybe we are not able to define generics in methods. Yeah, okay. I know the reason. Because you cannot type a method without in a class. So this method is actually being under the class of main window. So I have to define that generic type constraint under this. So therefore, I am not able to define a constraint under the method. To do that, I have to do it like this. Class like this, and where t struct, and then inside this I have to define my generic method. Okay, we'll make it public. So now I can use this with constraint of this. Okay, so it says oh, I cannot use this because we are getting t from here. So interesting. Why? Why is this giving an error? Oh, I know why. Because I have to provide a data like this and return data. Okay. Okay, now it works. Okay. Okay. And mm, okay, so this is the overriding of a common extension. Okay. Okay, I think this was a great lecture. Okay. So hopefully see you next week. Try to stay away, try to avoid from coronavirus. It's extremely dangerous and you should already know it by now. Today, a father of one of my friends has passed away, or my father's friend, we can say that. And so, be careful. Hopefully, see you next week. End of lecture. I will upload this to our GitHub repository. Okay. Okay. See you.